me to introduce you to Noah and Itai. They've been a couple for many years, and they've been trying to start a family. Unfortunately, they had the difficulties in convincing naturally, so they decided to seek for an assistant from a fertility clinic. Now meet Dr. Tsarfati. She is a fertility specialist who runs her own clinic. Noah and Itai arrived to her clinic, and she started to ask them about their conceiving attempts, and she wants to see their medical records. She recommends them to do some blood tests, some ultrasound scans, some hormonal tests to assess their fertility condition. And eventually they decide that they want to proceed with IVF treatment. Okay, so Dr. Tsarfati she wants to prepare for this treatment. She needs to decide what is the best day for egg retrieval. Therefore, she needs to know what was the highest level of a hormone called estradiol in Noah's hormonal tests. Estradiol is hormone is very crucial in the ovulation process. So Dr. Tsarfati accesses her computer and she starts to search for this information. But she just can't find the answer for this simple question. Where are the hormonal tests stored? In which system should I check? And where is the... Noah sent me her medical summary. Where is it? Where can I find it? As you already understand, one of the main challenges of doctors is how they can query the medical data of their patients and get answers. While this data exists in the databases, it's deeply buried and they have no easily access for it. So this is exactly what we're going to talk about today. This was the challenge that we wanted to solve for the doctors and medical care teams in the fertility clinics we collaborate with at MB. We are a startup, and we specialize in developing a platform for fertility treatment monitoring, specifically for doctors and medical care teams. So today I'm going to share with you the development process we had at MB for our tool. What were our considerations, which technologies we considered, and I hope to convince you why we eventually chose to use LLMs together with GraphQL for this tool. I will share with you also code and some tips. I am Shirli Di-Castro Shashua. I'm from Israel. Miei genitori sono da Roma, allora so parlare italiano abbastanza bene. I'm a senior data scientist at MB. In my professional background, I have BSc in biomedical engineering and a PhD in reinforcement learning. This is me at my most favorite vacation, skiing. And the reason I put these images here is just that the last time I visited Italy was just 2 months ago when I went for skiing in beautiful Sella Ronda. I'm a mother of 3 sweet children, Daniel, Nadav, and Shaked. And as you know, many couples are trying to start a family, and I'm very excited, together with the MB team, to be part of their journey. Okay, so this is Dana. Dana is our CTO at MB. One day she comes to us and tells us, guys, the doctors at the fertility clinics, they want us to develop them a tool where they can just ask questions about the medical data of the patients, like the question of Dr. Tsarfati, what was the highest estradiol level for Noah Sheleg, and just get the answer. That's it. They don't want to search for the information. They just want it fast and now. They have no time. So if you want to develop this kind of tool for your organization, this is your time to pay attention and listen. We took this mission on ourselves. Yaron, who is the backend developer, and me, Shirley, the data scientist, who at this point I became the professional Gen AI of the company. So we started with defining what is the flow of our tool. So on the one hand, we have the question that we receive from the doctor. And on the other hand, we have the answer that we would like to provide him in free-form language. So we start with the question. What do we assume about the questions of the doctors? First, we assume that the question is going to be in free-form language, just like a doctor asks his colleague. Next, we assume that the question may be complex. The doctor may ask more than one question. He may ask a question that requires us to take several databases in order to answer this question. And we want our tool to be very flexible to any kind of doctor's question. This is the thing. We do not know what the doctor is going to ask. He can ask about one patient. He can ask about several patients. He can ask about clinic activity. We have no clue. So we must that our tool will be flexible to any kind of input. What about the answer we would like to provide to the doctor? First, we have to make sure that our answer will be authorized. That means that only staff members that have permission to see the data that they are asking about will receive the answer, the authorized data in the answer. Next, we want to make sure that the answer is relevant and accurate. Relevant, that the response really answers the question, and accurate, that in the answer we will have only real data from the database. We don't want that the answer will include any incorrect information. Oh no, Shirley, how are we going to do it? How are we going to develop a tool that is accurate and flexible and secured all at once? Relax, Yaron. Don't you know, didn't you hear about LLMs, large language models? They've been tremendously developed in the past few years, and they allow us today to tackle tasks that we could only dream of. Large language models can summarize, can translate, can generate code, can answer questions. This is exactly what we need. Okay, so how do we combine LLMs in our tool? Naively, when we get the question from the doctor, what we would like to do is just to send it to an LLM, give him the relevant data, give him the doctor's question, and tell the LLM your task is to generate an answer based on the questions of the question of the doctor in free-form language. Sounds easy, right? But here's the problem. How do we make sure that we send the LLM only the relevant data from the database? We do not want to send him all of our data from the database. It's a huge amount. Our task is to narrow it down, to focus, to provide to the LLM only the data that he needs in order to answer the doctor's question. So how are we going to do it? We simply use another LLM for this task. So this is the first LLM that we're going to use. To the first LLM, we're going to provide the doctor's question, but instead of providing him all of the data from the database, we'll provide him the database structure, the names of the tables, of the fields, and we will ask him, instead of generate me the answer, generate me a database query that will fetch data from the database that is relevant to the doctor's question. Then, hopefully, the LLM will generate me this kind of query. I'll run it on the database. We'll get the relevant data from the database. And now we can do what we wanted. We can now ask again the LLM, here is the doctor question. Now here is the relevant data because we already fetched it. Now if you can please generate me the final answer. So now what we've left is to decide how are we going to query the database? Which language or that database query language are we going to choose? And this will be our focus. Listen to me, Yaron. I see tutorials. I attend meetups. I get updated in the last developments, and I tell you that what we need to do is to ask the LLM to generate an SQL query. Then the LLM will generate the SQL query according to the doctor question, according to the database structure that we'll give him. We'll run it on the database. We'll get the response from the database. Then we'll send it again to the LLM, and we'll get the final answer. Easy, easy. The combination of LLM and SQL, it gives us the flexibility we wanted. It gives us the ability to answer complex questions, because in SQL you can do joins with all the tables. You can filter on all the fields. It's perfect for us. No. Shirley, there is no way. There's no way I'm letting an LLM generate an SQL code that's going to run directly on my database. No way, this is so not secured. What if the LLM will generate a code, an SQL query that will delete me tables from the database? Or what if the LLM will generate me a SQL query that will fetch all the data and will crash my system? There is no way. Relax, Yaron. This is what all the blogs are saying we need to do. Even LangChain, they say so. This is what we need to do. No, Shirley, I'm sorry, there is no way I'm going with it. There's also the PII problem that we need to consider. PII, personally identifiable information, it's crucial. As we are a healthcare company, we're bound with regulation. So we need to make sure that there is no way no one can link between a patient's personal data and the patient's medical records. So when you are saying that the LLM will generate an SQL query, the LLM will going to filter according to the patient's name. But here's the thing, we do not store the patient's name in our database. So you just cannot run this query. Instead, we have separate databases. We have a database for medical records. We have a database for personal information. What links between them is a patient ID. Okay, Yaron, so what's the problem? Okay, so forget about patient names. We will provide the LLM with the patient ID, and then the LLM will produce an SQL query with the patient ID. That's it. This query we can run. I'm sorry, Shirley, there is no way. It's not enough. There is also the roles problem. The roles problem. Yes, the roles problem. Again, we are a healthcare company. We need to follow regulations. So we have defined distinct roles for each staff member. This to make sure that a doctor, for example, cannot access to data that it's not the data of its own patients. So how your LLM is going to generate an SQL query that will know how to limit the access to only authorized staff members? I know. What we'll do is we'll do an SQL validation. We'll validate the query of the LLM, and if needed, we will append additional filters that will make sure that only authorized people can access this data. I'm sorry, Shirley, it's not going to happen. The combination of LLM and SQL is not secured. If you want, I agree that the LLM will generate us a REST API request. With REST API, everything is controlled. The client sends HTTP request to the server, and then it gets back the data. Since I am the one who is implemented in the backend, I have full control of what data can be requested and which data I give back to the client. The combination of LLM and REST API is secured. I can implement any safeguards I want to make sure that there is no accidental deletion of my database and that only authorized people can get the data they need. No, Yaron, not the REST API. No, you know that we have the problem of the overfetching and the underfetching. And it's all because in REST API, the response is predefined. This is a big problem. In overfetching, REST API can give you more data that you need in order to answer the question. So, for example, Dr. Tsafati question, what she needs is only the information about the estradiol test of Noah. So if the LLM is going to generate requests according to REST API, he will use, I guess, the lab test results endpoint that we have. But this endpoint that you implemented, it fetches all the tests of the patients. But we don't need it. It's too much data. And also inside the estradiol, there are many irrelevant fields for this question, and it can overload our database and can slow things down. And there's also the underfetching problem, which is the same thing, but from the other side. REST API can bring you less data that you need in order to answer the question. For example, Dr. Tsafati may need, I know, for the lab test, she needs which cycle it was, or when was it ordered, but you did not predefine it in the response. So if the LLM needs this information in order to answer the question, he will need to generate additional queries for other endpoints, and we can't get away from it. We'll need to generate many new endpoints in order to have all the data types that we may be requested by the doctor. The combination of LLM and REST API, we wanted flexibility, we wanted to be able to answer complex questions. Forget it. REST API is ruining it for us. I want us to proceed with SQL. There is no way, Shirli. I agree only for REST API. Oof. Oof. Actually, I understood him. He's got a point. The database is sacred, and any code that is going to be run directly on the database has to be generated by someone who knows what he's requesting, so the database won't crash. And LLMs, with all due respect, they're unexpectable, and they may generate sometimes stupid things. So we just can't allow ourselves to let LLM to generate SQL code that will be run directly on our database. Yaron, what do you say about GraphQL? GraphQL, interesting. Let's see what it means. So GraphQL is a language for query data from the database. It has only one endpoint. Remember we said that REST API, we had to have many endpoints for each of the data types we wanted to return to the clients. GraphQL has only one endpoint. And also remember that in REST API we had the problem of overfetching and underfetching. In GraphQL we have exact fetching. The client can request only the data he needs and get back only the data that he needs. And this is going to be according to three components of GraphQL: schema, query, and resolver. Okay, so schema. Schema, in GraphQL you can define types that you allow the client to request. So in our example, we can define a patient type with all the relevant fields. We can define a lab test results with all the relevant fields. And of course, we can define additional types for the fertility clinic. There is a special type in GraphQL called query, which defines what the client can request in order to get the data back. So here's an example of a query that may answer Dr. Tsarfati question. So the query may include the patient data, the name. You can see that the query does not include date of birth. I mean, the client could ask this field, but it's not relevant for the question of the doctor, so we don't need it. And also we can request the lab test results. In GraphQL, we can also filter, so we can even make it more narrow and get only the data that we need in order to answer the doctor's question. And last, we have the resolver. The resolver is like a bunch of functions that needs to define how we're going to return to the client the data that we defined in the schema. If we define it, the client can ask for a patient data. We need it in the resolver to decide how we're going to fetch it and how we're going to return it to the client. So in the resolver, it's where all the magic happens. The resolver contains a lot of functions that we as developers are going to write. So we can, inside the resolver functions, we can put all the restrictions that we need in order to make sure that we give back the client only the data that we agree that is going to receive. So it allows us to have a more secured fetch, because the GraphQL query is not going to be run directly on the database. It's going to go through the resolver trainer. It allows us to give back the data only to authorized. We can implement this inside the resolver function. And it also gives us a lot of flexibility, because in the resolver we can implement all the filters that we want and all the combination between different databases. For example, we had a problem with patient name. So LLMs, they understand good language, right? Natural language. So in the query, they can ask for the first name and last name. But inside the resolver, we will implement that if we get a name, we need to check if the name, we have it in the database and we can fetch the user ID. If we have, for the same name, many users ID, so we can give back an error. Okay, and we can make sure that what we give back is authorized, and it gives us a lot of flexibility. The combination of LLM and GraphQL is secured. Shirley, I really like it. I like it too here on. The combination of LLM and GraphQL gives us the flexibility and the ability to address complex questions. Okay, the only challenge with GraphQL is it will take us time and money to develop it because it's not implemented in our system. REST API, we already have implemented on our databases. SQL is just run it on the database. But GraphQL, it takes time and development time to implement it. But we decided to go for it. So now I'm going to show you how the flow is looked with the combination of LLM and GraphQL. So we said we have the doctor's question, and we sent to the first LLM the doctor's question, and we sent him the GraphQL schema, all the types, okay, that we defined, and we asked the LLM to generate a GraphQL query. So this is how it looks like. First, we defined a class of GraphQL chain. We initialize it with the LLM we want to use. We can use, here, it's an example with OpenAI, but it can be another LLM. And we initialize with the prompt for, first the prompt for the GraphQL query, and the second is the prompt for the final answer. So this is a prompt. It looks very big and ugly, but I'm going to explain what it includes. So the prompt that we send to the LLM has 5 components. First, we're going to tell the LLM what is his task. We're going to say, LLM, you are a GraphQL expert. You know how to write GraphQL queries. Your task is to write the GraphQL query according to, first, the doctor question, and we're going to put the doctor question here, and according to the GraphQL schema, all the types we have. And according to, we also decided to add the resolver signature. You remember we said that resolver is a function, okay? The function, in the function, the LLM can understand what filters he can use, what are the types of the fields, okay? So if we give him also the resolver function, it helps him to make more good synthetically GraphQL queries. Also, we're going to tell the LLM how we would like the output to be. We decided to tell him that we want the output to be a GraphQL query, of course, but also we asked him to give us an explanation for what the GraphQL query is fetching. Why is it important? Because we wanted the doctors to know what data the LLM based on his answer, okay? Because maybe he fetched data that is not what they ask for. So it's important that they understand what was the data that was fetched. And we give him example. It's a good practice in working with LLMs to give examples of what you're looking for. So we can give him, in the examples, a possible question, how we expect a GraphQL query to be synthetically correct. And we also wanted him to give us explanation, so how we expect the explanations to look like. This structure is very important because it will help us to parse it much easier later. Okay, so this is how it looks. It's a function inside the class. So in the GraphQL prompt, it's an F string, and now in runtime, we put the doctor question and the GraphQL schema. We send it to the LLM. So we get the GraphQL query. We need to check it, if it's synthetically okay, or other checks that we want to do. And then we can run it and get the database results. Okay, so this is where we are on the flow. The LLM generates a GraphQL query according to Dr. Sarfati question. Okay, so she wants to know what was the highest level of estradiol of Noah Sheleg. So the GraphQL query is going to filter on the name of Noah, on which lab test estradiol, and this is the fields that are interesting in order to answer the question. And now when we run it and we get the results from GraphQL, and this is the opportunity to see how GraphQL response looks like, you can see that all the fields in the response are exactly the fields that we requested, nothing more and nothing less. So we get just the data that we want. So here we get all the estradiol tests of Noah. So now when we ask again the LLM to produce an answer, what it will look like, we ask what is the highest level. We will append to the question this result, okay? And now the LLM has just the relevant data, and he can answer the question, Okay, so this is the second time we send the prompt to the LLM and the task now is just give us an answer based on the database response. And this is how it looks in the code. Again, we have a final answer prompt. It's another prompt, much shorter, very simple. It's an F string that we put to the question and the database result. We ask the LLM for an answer. And now we need to parse it. Remember that I told you that we have a specific structure. So we need to parse it. And then we validate the final answer, and this is what we give back. Okay, so you may ask yourselves now, what about validation? And you're absolutely right. So where do we do validations? We do it in where we have the outputs of the LLM. So we have two outputs, when it generates the GraphQL query and when it generates the final answer. So how can we validate the GraphQL query? First, of course, we can check syntax. Remember, you as the developers, you're going to write the GraphQL schema, you're going to write the GraphQL resolver, so you know exactly what fields you allow to filter, you know the types of each field, you can very easily check if the syntax is correct. Second thing is that you just can run the query. Remember, with SQL, we were very afraid to run the query because it was directly on the database. But here, we're not afraid because if we run the query, what the query is going to meet is the resolver. So the worst thing that can happen is that we get error. But it's not going to damage our database. So with error, we can handle. And how are we validating the final answer? So first of all, we decided that we're going to declare that the answer was generated by AI. This is very, very important. We want to train the doctors to get used, that they need to be very critical about the answers that they see, and they need to know it was generated by AI. Second, we decided that we always will give, along with the natural English answer, also the results from the database. So they can always compare and see, because the result of the database is the real data. Okay? It's the real data, and we trust it. The answer from the LLM, this is where it can go wrong, right? So they can always compare. And we also use NLP tools to extract interesting entities, and we can always compare them to the database results that we have to make sure that there are no incorrect entities or values. That's it. What I would like you to take from this talk. First of all, embrace Gen AI. In Italiano si dice abbracciatelo. Because as you can see, it is possible and very beneficial to implement generative AI technology into the products that you would like to develop. It's true that LLMs may be unexpected and may generate, we don't know what they're going to generate, and they have a lot of uncertainty, and we cannot control them all the time, and we as developers and data scientists will have control. But here's the thing, with this uncertainty, this is where comes all the opportunities. So opportunity to develop tools that up to 1 year ago we couldn't even dream of. So with the right planning and with the deep understanding of who are your users, what are the requirements of your tool, what is the data and security limitations you have, with LLMs, the sky is the limit. Thank you very much. It was really nice talking today.
Thank you very much. Unfortunately, we don't have time for questions, so you can ask Shirli afterwards.
You can approach me later for questions, no problem.
Thank you.
Thank you.